All right, we're back. It's 1 o'clock Eastern Time. Our next speaker is Coraline Ada Ehmke. Coraline is a speaker, author, teacher, open source advocate, and technologist with 20 years of experience in developing apps for the web. As a founding member of LGBT Tech, cultureoffset.org, and contributor-covenant.org, she works diligently to promote diversity and inclusivity in the tech industry. Her current interests include refactoring, code analytics, and artificial intelligence. I also want to just add a personal note. I've gotten to know Coraline over the last few months as she's been on Ruby Rogues, and I think she is a wonderful person. And I'm really excited for this talk. So I'm going to go ahead and turn it over to you and take it away. It's aesthetics and the evolution of code.
Okay, can you hear me okay?
Yep, loud and clear.
All right. So as Chuck said, the talk is aesthetics and the evolution of code. You can learn all about me at my website, where.coraline.codes, which has to be one of the best vanity URLs in the world. You can find me on Twitter at Coraline Ada. I tweet about Ruby and intersectional feminism, and I exchange puns with Tinderlove. I work for a company called Instructure. We make learning management systems for K-12, universities, and corporate markets. We have millions of users, and I've learned a lot working with this company, and my particular job right now is refactoring. So I spend a lot of time thinking about the context in which we write code, from its creative origins to the process itself, all the way to the impact of the code has on the greater community. Like many of you, I work with legacy code quite a bit. I'm part of a refactoring team, as I mentioned, working on breaking up our old monolithic application into something more manageable. And I want to point out the fact that I dislike the term legacy as a pejorative. A legacy is something that's passed down from one generation to another, and it's our own faults if we treat it as a curse instead of a gift. So working with legacy code has given me a perspective on what quality means and how our pursuit of quality changes the way we approach a code base or technical challenge. I believe there's a particular way that we judge code, and that by thinking about how our own code will be judged by future developers, we can write better code here and now. At the heart of our experience with code is the concept of elegance, and it's a very loaded word. We're captive to the notion of elegance, but what exactly do we mean by it? Maybe it's like Lewis Carroll wrote in Alice's Adventures in Wonderland, one of my favorite books growing up. Humpty Dumpty and Alice were arguing over the use of the word glory, and Alice said, I don't think you can make up the definition for a word, basically. And Humpty Dumpty says, when I use a word, it means exactly what I intend it to mean, neither more nor less. It's a matter of which is to be master, that's all. Does that mean that elegance is undefinable? Well, it just so happens that there's an entire science devoted to the notion of beauty and elegance, and I'd like to explore it with you today. The science is called aesthetics, and aesthetic theory is something we're going to be talking about next. Aesthetics is a study of how we experience beauty. It's an experiential phenomenon. Normally, it's considered a sensory phenomenon, but it can also be a cognitive appreciation of beauty as well. There are four main approaches, theoretical approaches to aesthetics. The first is pluralism, which states that each person perceives things differently and derives different meaning from an experience. Therefore, there's no absolute truth in perception. You might say that when we look at something blue, we all see a different blue. That would be pluralism. Next is hybridism. Hybridism perception and meaning derive from a rich common experience, and this common representation is considered truthful. You might say that we all see more or less the same blue when we look at an object that's blue. Absolutism says that aesthetic beauty derives from truth and provability. Because of the wavelengths of light striking our eyes, hitting the backs of our retina, we all interpret the same blue. the same way. And finally, there's eclecticism, which promotes the idea of the application of different interpretations contextually rather than adhering to a single set of standards. It allows for multiple paths to the truth, so we all see blue, but we may interpret it differently. The effect of our aesthetic sensibilities can also be deliberate, and this is called applied aesthetics. Think of a physical structure. A physical structure has basic attributes. It is made of materials for a specific utility and built at a specific cost. But if all we looked at were these four attributes, then we'd build and live in concrete boxes. Through applied aesthetics, deliberately injecting aesthetic qualities, these buildings can be elevated to new dimensions that are not just utilitarian, but an expression and an experience, and this makes our interactions more pleasing. Both of these buildings serve a function, but the one on the left has an aesthetic quality that the one on the right does not. As human beings, we want to be surrounded by beautiful things, and we want to dwell in structures that are beautiful. This is Bacon's Castle, Virginia's oldest documented brick building. It was built in 1665. It got its name from soldiers who barracked there during Bacon's Rebellion in 1676. It's been preserved by private and governmental funds for 350 years. This is a Soviet-era building built in the brutalist style. Brutalism emerged in the ashes of World War II when materials became readily available to build structures very quickly and easily to replace the burned out rubble of bombed out cities. It's very unlikely that a building like this will be preserved for 350 years. Code is the same way. We don't want to maintain monolithic applications with brutalist architecture, utilitarian code bases. We want to create small and elegant programs that interact with each other in predictable and pleasing ways. Elegance is an aesthetic experience. It's about perfectly conforming to a set of imperfect standards with no extraneous lines or rough edges. Elegance in code is a result of a mysterious process that we don't fully understand. Elegance in nature is largely the result of evolution. It's really important that we define our terms here, so I'm going to give a brief primer on evolution. If you grew up in the South like I did, this might be your first introduction to the topic. At the heart, there are genotypes. This is the genetic information that will determine physical characteristics. The genotype might specify things like whether or not an organism has eye stalks, what its fur patterns are, or how thick its stems are. When these genotypes are expressed, they're phenotypes. This is the physical representation of the genotype. Natural selection is a process by which traits become more or less common in a population depending on their impact on reproductive success. A canonical example of natural selection is the forest moth. Prior to the Industrial Revolution, light-colored moths had an evolutionary advantage because they blended in with tree bark better and were thus less susceptible to predators. When the Industrial Revolution started and soot became a feature of these trees in the forest near factories, darker colored moths gained an evolutionary advantage and began to outnumber their light-colored counterparts. There's also artificial selection, in which humans intervene and deliberately breed for specific desirable traits. And that's what we'll talk about next. Can aesthetics be a factor in evolution? I'd like to introduce you to John Chapman, better known as Johnny Appleseed, who lived in the 1700s, famously wore a shirt made out of a coffee sack and traveled with bushels of apple seeds. It's important to note that in the 1700s, sweetness was a luxury. Sugar plantations using slave labor were not yet operational, and the only honeybees that were available were imported from Europe. So really the only sweetness for most people was fruit. When we think of fruit today, we might think of a red delicious apple, which is aesthetically pleasing as well as very tasty. Every apple contains 3 to 8 seeds, but if you take the seeds from a red delicious apple and plant them, you don't get a red delicious apple tree. You mainly get fruit that's inedible. Early colonists would bring branches with them to graft onto other trees to produce fruit that was recognizable. When you plant apple seeds, you're going to get something like this. It's an inedible fruit, just like the orchards produced that John Chapman planted. So was John Chapman stupid for planting orchards that yielded inedible fruit? The fruit that he produced wasn't intended for eating, it was intended for hard cider. Hard cider has the advantage of being preservable much longer than fresh fruit and makes it easy to get drunk as well, so it had some distinct advantages. So the orchards that he planted and sold to settlers were actually quite profitable. Until the 1830s, when the temperance movement arose and there was a big movement to ban alcohol altogether. Apple orchards were in danger of losing their viability and their value. So apple orchards started producing fruit that once again was edible. And in a propaganda campaign, they started touting the health benefits of the fruit as well. This is where an apple a day keeps the doctor away came from. Essentially, the orchard owners were boosting evolutionary forces through artificial selection to produce something that was in line with aesthetic demand. So the genetic expression of the apple has changed tremendously over the last 300 years in response to changing aesthetic desires on the part of consumers. Precious boughs were brought on ships from Europe for grafting, but cider apples dominated until the mid-1800s. In the late 1800s, there were literally thousands of varieties of apples available, and today we have about 20 available to us readily. Whether we guide their changes through crossbreeding or inadvertently do the same thing based on selecting variations that please our aesthetic preferences, we can have a direct effect on the evolution of things in our everyday lives. So is aesthetics an integral part of evolution, or is it an outside influence imposed by humans on the physical world? You may have heard of a book called The Selfish Gene, which explores the concept of what a gene wants. The idea was first proposed by an evolutionary biologist named George C. Williams. He pointed out that since evolution is about surviving genes, that it can be an interesting perspective to take the interests of the gene in mind, rather than centering evolution on the perspective of an organism or a species. One of the interesting things that arose from this line of research, this line of inquiry, was something called the green beard effect. So imagine that there's a gene that produces green beards in men and a tendency to treat other green beards nicely. This can be thought of as genetic self-recognition, in which a gene in one individual directs benefits to other individuals that possess the gene. But because two green beards can't reproduce, such genes are essentially selfish, benefiting themselves without regard to the fate of the offspring of the organism. The green beard effect manifests in technology as a tendency to rely on and support libraries and apps written in the same language, and even the development of entire communities around a given language. This isn't just for our own benefit, but actually benefits the language itself. Technology is playing a different game than we are. So we might ask ourselves, if we apply the notion of the selfish gene to code, what does code want? I think there are three main things. Code wants to be ubiquitous. It wants to be on every device, from our phones to our coffee makers. Technology wants to be universal. It wants to be as applicable to as many problems as possible. Think of the API idea. The API idea has changed dramatically over the past 10 or 20 years, starting with things like XML RPC to SOAP to our current implementations of JSON. The API paradigm has been evolving in response to changing technologies, but it is a universal paradigm. Code also wants to be long-lived as possible. Unix is one of the most long-lived programs in existence, and its underlying philosophy of simple components and openness to new protocols give it evolutionary advantages. So, having explored what code wants, let's think about how code gets what it wants. Flexibility. Flexibility of a given technology or language encourages specialization, reducing the cost of staying with that language versus switching. By being extensible, meaning that the language can be used for novel applications beyond the scope of what its designers intended. By being novel, new language features, supported new methodologies and coding techniques are a way that existing technologies keep us constantly engaged and excited. And finally, by being entrenched. This brings to mind the fallacy of sunk money. Imagine a poker player who's lost $1,000 in a night. That poker player might be loath to get up from the table because he or she has so much invested in the game already. And technology can be the same way. It can be too expensive to switch technologies midstream. And think of the effects of IE6, which was built, for which lots of intranets were built, and how insidious that technology became and how long-lived. So is it fair to compare evolution to the natural evolution in the natural world of programming? How do the basic principles of evolution map? We might think of the language as a genotype, which defines and provides access to allowable features and functionality to the program. This genotype is expressed in a phenotype as an application. There are environmental pressures on technologies. They have to compete in a highly interconnected environment. There are physical and logical platforms, operating systems, infrastructure, protocols to support, and of course, survival on the internet at large. Competitive environment brings natural selection to mind. The reflection of deliberate intervention in evolution can be thought of in terms of support and maintenance. It's the functional equivalent of a generation is a version, or more interestingly, a cycle of attention from a system's inception through to its first refactor. Artificial selection in a technological sense is a sort of guided evolution brought about by maintenance and support, following a roadmap to keep a technology current and relevant. So we've seen how aesthetics can affect genetic expressions in organisms. Can the same thing happen with algorithms? How do we judge the aesthetics of a programming language? There are 5 main ways that we interact with a programming language: through source code, through a user interface, through the command line, through the API, and through its documentation. The API comprises the syntax, keywords, methods, and metaphorical design of a programming language. The command line allows us to launch programs and interact through an executable environment, in the case of Ruby, an IRB connection. Documentation: how well is the language documented? How eligible and accessible is the documentation? How easy it is to parse and understand? How readable source code is, and how easy it is for a developer to parse it and understand it. And finally, the user interface, which governs the way that we interact with code, either through a GUI, a website, or through the command line. In 2014, I conducted a survey of 6 languages and asked people to rate them according to those 5 characteristics: the API, the command line interface, the documentation, the user interface, and the readability. I used the data from this study to feed what I call an aesthetic index. The longer the bar, the more aesthetically pleasing the language is to the respondents. Python came out in first place, with Ruby in a close second, JavaScript and C# following that, and Java and PHP lagging behind. It's interesting to map the aesthetic classification of these languages to their popularity. With the exception of JavaScript, which is sort of an outlier because there's no viable alternative to scripting on the client side, there's a confluence between the popularity of the language and its aesthetic qualities. So that's languages. What about the aesthetic characteristics of code, the phenotype in our evolutionary metaphor? I think there are basically 4 interconnected aesthetic principles that are applicable. The first is correctness, which falls into the absolutist sphere of aesthetic theory. But I don't think that correctness alone is enough to make code aesthetically pleasing. This is Edsker Dijkstra, a Dutch computer scientist. He believes that programming is an extension of applied mathematics, and that the beauty of code lies in its correctness and provability. So when I started getting back into artificial intelligence, I found this book and got very excited about it. It's called Clever Algorithms, Nature-Inspired Programming Recipes. All of the examples are in Ruby, and they're standardized algorithms derived from natural systems. I got very excited. The only way this book could be more perfect for me is if Douglas Hofstadter delivered it on the back of a giant raven and dropped it into my lap. Then I made the mistake of opening the book. I found methods like drand1ben with a method signature that's 14 arguments long. Yuck. Or this beast of a method, which goes on for 118 lines with no objects in sight. It's purely procedural code. Yuck. There are 2 places where code like this can be considered beautiful: in the eyes of its creator and in bizarro world. So elegance is definitely more than correctness. The second aesthetic measure is performance. I consider performance to be understood by applying a hybrid perspective, because while performance can be measured fairly precisely, the experience of performance is very subjective. Consider a database query that's improved whose speed is improved by 50%. that improvement won't be the same as a 50% decrease in page load time. That change is perceived very differently in the eyes of the end user. Brevity, the third aesthetic measure, this is best understood by applying the eclecticism filter. We instinctively recoil from bloated controllers, from God models with thousands of lines of code, deeply nested conditionals. But short code, brief code is very hard to write. I'm reminded of Blaise Pascal's apology. I wrote you a long letter because I didn't have time to write you a short one. The brevity can negatively affect readability. Readability is absolutely subjective, but it's important to remember that we write code for humans first and computers second. We write it for a particular audience. Unreadable code can be just as expensive to maintain as incorrect code. So we use style guides and tools like Rubocop to try and quantify and enforce our aesthetic principles. We favor short methods. We favor small classes. We favor lines of code that are less than 80 characters. I think that these four qualities combine in some elusive, mysterious way to create an aesthetic experience of code and a sense of what we call elegance. I had a conversation with someone recently where they said, if only we could quantify elegance, so I decided to give it a try. I created a grid, a quadrant grid, with correctness and performance, concision and readability. And this is something we can use to map interpretations of our code onto. So for example, code with this characteristic is very readable but not very concise, but it's also correct and highly performant. Code like this is more concise and less readable. That's an extreme case of the same sort of approach to code, and more readable and correct and performant. But what we're striving for is symmetry in this graph, a balance between all four aesthetic qualities. So why does all this matter? Einstein wrote that after a certain level of technological skill is achieved, science and art tend to coalesce in aesthetic plasticity and form, and that the best scientists are also artists. So are we allowing ourselves to be artists? Are we allowing ourselves the freedom to create elegant code? Consider the modern startup culture, where business people spend time dreaming up applications with no backing business models and go off in search of technical co-founders. We agree to an MVP, and this is a document that we sign with our own blood. It must be delivered by insert arbitrary date here, or the world will come to an end because there's no Facebook for Goldfish. What results is brutalist software architecture, rigid, cold, and ugly, but delivered quickly and cheaply. This puts the demand for our labor at odds with our aesthetic sensibilities. We want to build this, cathedrals of code that are functional and elegant and timeless. But we're asked to build this, quickly constructed brutalist monstrosities with short-term value but no aesthetic appeal at all. I don't want to write code for that devil, and neither should you. So why do we write code? Is it for money? Is it for job security? Or is it because we're attracted to the infinite potential of helping us solve problems by creating something out of nothing? And who do we write code for? Is it interpreters, compilers, stakeholders, end users? I think we primarily write code for other developers. We have to consider the aesthetic sensibilities of the people who will interact with our code later, not just our own. We have to be flexible and understand that elegance is subjective. In Ernie Miller's Humane Development Manifesto, he writes that we are humans working with humans to develop software for the benefit of humans. I think this is an important assertion and one that we should keep in mind as we work to develop our code. Why do we care about quality? Is it just a matter of maintainability and extensibility? Or is it the fact that our names are on those commits? We don't want someone down the road to get blamed and start calling us names. We care about quality because the code we write is an extension of ourselves. Aesthetic appeal is a measure of quality, and I would argue it's one of the most important measures, not necessarily to stakeholders, but to the people who really own the code, the developers. Architecture without aesthetics is brutalism. Code without aesthetics is a commodity. Maybe some of you are comfortable getting paid to write crappy code under bad circumstances for a big paycheck, but I really doubt it. So don't do it. Care about your code. Recognize and respond to its needs. Create a symbiotic relationship with it. Guide its evolution and let yourself evolve in the process. Consider the experience of writing it and reading it. I think it's important for us to think about our relationship to our work. We're going to delve for just a moment into economic theory, in particular, one of the theories put forth by Karl Marx. He wrote about the theory of alienation, which describes the estrangement of people from aspects of their human nature as a result of being a mechanistic part of society. At its heart is the idea that a worker can lose the ability to determine their life and destiny when deprived of the right to think of themselves as a director of their actions, to determine the character of their actions, to define relationships with other people, and to own the things produced by their own labor. Workers as an economic entity are directed to goals that are dictated by those who own the means of production in order to extract the maximum amount of value in a business situation. It comes down to a question of ownership. Who owns the product of our labor? Since we're being paid by our employers, unless we're working for theoretical options in lieu of a paycheck, our employers own our code. But we need enough autonomy to determine the worth and character of our work, to think for ourselves, and to own the relationship of our work to the world and our peers and our community. We increasingly prefer to call ourselves craftspeople or artisans, but if we're just cranking out anonymous code for self-proclaimed entrepreneurs, our code becomes a commodity. And like Marx predicted, we become alienated from the product of our labor. And you know what? Artisans don't work in code factories. We have the power to decide what form our code will take. Code wants to be universal, ubiquitous, and it's willing to be flexible to ensure that we stay involved as it evolves. We can blindly participate in this process like the forest moths during the Industrial Revolution, or we can actively and intentionally engage with our code to create experiences of pleasure for ourselves and others. In the end, it's our responsibility to tend to our code orchards, to make the fruit of our labor beautiful and pleasing. I hope I've inspired you, and I hope I've inspired you to go and build something beautiful. Thank you.
All right. Does anyone have any questions for Coraline?
Thank you, David and Chris. When I gave this presentation last, some people had questions about how to combat the effect of people who are pushing for code to be delivered very, very quickly, and how that interacts with our ability to produce code that is aesthetically pleasing. So Thomas just asked, or someone just asked the question of how do we get coworkers to care about the quality of code as much as we do? I think that's in line with that question. I think we have to set good examples, especially if you have a team with new developers, maybe juniors or mid-level developers. They're more likely to copy the code that is already in place and copy those patterns and apply those patterns because they're afraid of making changes that are out of line with the quality standards of the organization. So setting a good example by ourselves writing good code creates a pattern that can be, or a template that can be copied and carried on even in our absence, which I think is an important way to make sure that we establish good patterns and we enable other people the freedom to create aesthetically pleasing code. Another way we can influence the quality of other people's code is by pairing. And when we pair, we can take an approach of asking questions like, is this the best approach to this problem? Is there a more elegant solution? We're asking, why did you choose that solution? Through a collaborative process and iterative process, we can arrive at code that is more aesthetically pleasing and that's also functional and performant and readable. Does that answer your question? Great. In terms of learning resources on aesthetic theory, I would start on Wikipedia. There's a long list of books that you can start reading up on it. There's also a book called Beautiful Code, which I would recommend. And there's another book called The Aesthetic Qualities of Code, which is also a really interesting read. Do I find that the aesthetics of Ruby was one of the important reasons why it attracted so many Java developers in the aughts? I would say definitely so. Ruby was designed to be a language that encourages developer happiness And I think we're happiest when we're writing aesthetically pleasing code. And that was definitely a big draw for me when I switched from Java to Ruby in 2007. The next question is, how would you approach a legacy unaesthetic app to become more aesthetic? I think if you take aesthetically pleasing code as one of the goals of a refactoring or the reduction of a technical debt problem, you can produce code that is more readable and more maintainable, which is something you can sell to management, and keep the idea of making it more aesthetically pleasing more or less yourself, but make that one of your own personal goals. Maybe you don't share with management. Did that answer your question, Federico? Awesome.
You ever find that there's a conflict between correctness and aesthetics?
If we focus overly much on any one aspect of those four components of aesthetics, I think we can get ourselves in trouble. There's definitely a dynamic tension between them, and that's why I put them at opposite sides of the grid. I think if we keep all four qualities in mind, we're definitely going to be making compromises as we work through a particular piece of code. But as long as we're deliberate about it, for example, performance might be an issue for a particular section of the code, and that might negatively impact how readable it is or how concise we can make it. Those are trade-offs that I think are best made in a deliberate manner, in a very thoughtful manner, and as a result, we can produce code that is the best for the job at hand and is as beautiful as we can possibly make it under those contexts or under those circumstances. I will, Chuck, do we have the ability to share some resources after the fact?
Mm-hmm.
Okay, I'll create a book list or a reading list for people and share that with you.
Yeah, everyone should have access to the community forum, so you can go ahead and just put those in there.
The results of the survey are not online, but I can certainly make those available as well. I think I had just under 100 respondents, so not very scientific, but I thought it was an interesting thought exercise anyway. Thank you, Thomas. Are there any more questions?
All right, I don't see any coming through, so thank you, Coraline. It was fascinating talk. Something that
Thank you very much.
it's something I think we don't often think as much about as we should. So
Right. Hopefully, I've inspired some new thinking on the topic. So I look forward to seeing some beautiful code being produced by the community. Thank you, everybody.
thank you.
Bye.
Bye. All right, well, we're going to go into our break a little bit early. Noel Rappin is up next, and that will be in about an hour. So, yeah, so we'll just look for that then. Also, I hit the record button a little late on Amos's talk, and so we're going to re-record that. Amos, if you're okay with it, we could do that now, or we can do it later this afternoon. And then we'll be back on then. So